Hello, how you doing? Have you heard the term reinforcement learning and you're not quite sure you know exactly what this is? Well, if so, then watch along with me for the next few minutes and I will quickly get you up to speed. Okay, let's get started. So what is reinforcement learning? Well, reinforcement learning, or RL for short, is a type of machine learning where an agent learns to make decisions by performing actions in an environment to maximize cumulative reward. The agent interacts with the environment, receiving feedback in the form of rewards, which guide its learning process and decision-making. In simple terms, RL is like teaching an AI system to learn from its mistakes and successes to achieve a goal efficiently. So why should you care about reinforcement learning? Well, RL in some ways resembles how humans and animals learn in the real world. So what makes RL so important and feels like robotics, gaming, and finance, where decision-making is crucial? Well, in plain English, RL is important because it enables machines to learn from experience and improve over time, just like we do. So what are the core components of reinforcement learning? Well, in an RL system, the agent is the learner or the decision maker, while the environment is the external system the agent interacts with. Actions are the possible moves the agent can make, and the states are the different situations or configurations the environment can be in. Simply put, RL involves an agent making decisions in an environment to achieve the best possible outcome. So how does the learning process work in RL? Well, the agent takes an action in a given state, and the environment responds by transitioning to the new state and providing a reward. Positive rewards encourage the agent to repeat actions, while negative rewards discourage certain actions, refining the agent's strategy. In layman terms, the agent learns by trial and error, getting better at making decisions over time. So what are the challenges in reinforcement learning? Well, balancing exploration and exploitation is a key challenge, as the agent must explore new actions while exploiting known rewarding actions. Recent advances in areas such as multi-agent reinforcement learning have expanded RL's capabilities in handling complex environments. To put it simply, RL is still evolving to tackle more complex problems, making it more powerful and versatile. So where is RL used? Well, games like chess and Go are ideal for RL as they allow for simulating millions of moves with low cost for mistakes. In contrast, driving a car presents challenges, as mistakes can be costly and dangerous, requiring careful simulation. Essentially, RL shines in environments where trial and error can be safely and efficiently simulated. So why is RL important for LLM-driven systems? In LLM-driven systems, RL can optimize LLMs by fine-tuning them based on user interactions and feedback. In essence, RL is vital because it empowers LLMs to become more intelligent, adaptive, and capable of solving real-world problems. Okay, so let me know what you think of reinforcement learning. Feel free to share your thoughts in the comments below. I want to hear what you think about this topic. Okay, thanks for watching.